In today's video, here is a nice problem coming from Bulgarian mathematical Olympiad. Here is the following statement: find all f as a continuous function for all x as a real number. Satisfy this following application. We get f of x equals f of x squared plus 1 over 4. Okay. Before we get started, we are going to identify this function. What's the behavior of this function first? Okay, before we get started. So I would be recommend to give the subscribe pre-game solution. Go ahead, pause this video when you come back to see the full solution. Okay, by the way, don't forget to hit the subscribe button, support our channel, like, comment, subscribe. Now let's jump into the solution. If you have f of x equals x squared, it's going to be in symmetry for this vertical axis, but it's not necessary to have the symmetry at the original. Okay, you can have the symmetry in different points. So for our example, if you take a look, if you check x equals 1 over 2, then plug x with half here, you get f of half is going to give us 1 over 4 plus 1 over 4, which is half. It seems to have a nice equality here, okay, between the left and the right side of this equation, which means at the point x equals 1 over 2 is going to be a symmetry. Okay, x half like this. So we're gonna happen. So if this one is an even function, is symmetry at point x0 equals half, which means this function is going to be increasing below this interval and decreasing above this interval, or inverse. So how are we gonna know below this point a function is increasing? So based on the point that we give here, if you submit the points x, for example x equals 1 over 4, then you get check f of 1 over 4 is going to give us 1 over 16 plus 1 over 4. F of 1 over 16 plus 1 over 4. Okay, so this value is a small value, but this one is bigger. So as you going up from 1 over 4 to half, this value is going to be also from the smaller to bigger. Okay, what does this mean? That means the function is going to be increasing below this point and below this point and decreasing above this point. Okay, so in the other word, if I'm going to take this one as a symmetry here, so our function is going to be like this. It's going to be like this, for example. Then a function start decreasing from this point. So we will have the same thing if we're going to a negative direction. For example, if you take in x equals minus 1 over 2, you will have also a symmetry here, because as you check in minus 1 over 2 here, I get also the same output, which is 1 over 2. Okay, so this function is, for example, so the important thing here, we get the same f of half, the same output. Okay, but this behavior is maybe is not real. The real one maybe is going to be a constant at the end. We are going to see that. Okay, now let's get rid of this one and start with our problem. So as we discussed before, we know f is an even function, because if you replace minus x into this function, we get here f of x squared plus 1 over 4, which is going to give us f of x is definitely the function is even. Okay, so we're clear with this point. Now let's move on to the second point. That's what we have. So which means, as we discussed before, since f is an even function, we are going to divide this one into two intervals where the function is going to change the behavior. Okay, we need just to discuss this one on the positive real numbers is enough. Okay, so for all x0 is super equal to 0, we will have x0 between 0 and half. So as we discussed before, so as we said, we are going to divide this one into two intervals. Okay, so let's put this one x0, x1 and all the way down to the xn as a recursion sequence. So let's define the function x sub n plus number 1 equals x n square plus quarter. Okay, so what you might say, why you choose this one, why do we have a different thing here? So we are going to connect this one with our function in order to make a small bridge where we can pass from this one to our setup. Okay, what our goal here, we have chosen this one as a increasing sequence. We are going to prove that, because since we get x0 between 0 and 1 over 2, which means the function is going to be, which means the sequence is going to be bounded. Okay, so we are going to prove, first table, we are going to prove x sub n between 0 and half, based on the basic case that we have here. Okay, we are going to do this one by the induction hypothesis. We are going to prove x sub n plus number 1 is also between 0 and half. Okay, so it's more simple here. We are going to square this one. We are going to start with this one as a true assumption. So we get 0 between x and square is inferior to 1 over 4. So adding the quarter on both sides, I get here quarter x sub n square plus quarter is inferior to 1 over 4 plus 1 over 4, which is half. Okay, so our simply, we know this one is definitely is a xn plus number 1. Okay, also this one is superior than 0, so thus xn plus number 1 is between 0 and half. Okay, so we have proven this one is true. So the next thing up, we are going to show this sequence is increasing. We are simply going to calculate the difference xn plus number 1 minus x. So we get x sub n plus number 1 minus x sub n. Replacing this one into this one here, I get xn square minus xn plus quarter. Okay, so this one is going to give us a perfect square here, which is x sub n minus half square. If I'm going to distribute, this one is going to give us this one exactly. Okay, so this one is superior to 0. So it implies x sub n plus number 1 is superior to x sub n, which means x sub n is increasing. X sub n is bounded between 0 and half. Also is increasing, which means it is a convergent. Okay, which means x sub n converge. The limit n goes towards infinity equals x0. Okay, or alpha. So we need to determine this alpha or x sub 0. Okay, so we get, since we get the limit of x sub n as n goes towards infinity is the same the limit of x sub n plus number 1, which equals x sub 0 or alpha. Okay, we need to determine this alpha, or simply by definition of the limits, I'm going to replace this one with alpha. So we get here alpha, which equals alpha square plus quarter. Okay, are applying the limit on both sides, we get to this one. So let's solve this quadratic binomial equation. I get alpha square minus alpha plus quarter equals 0. If you solve this equation, you get alpha equals half. It's more simple. As you're replacing alpha with half, you get quarter here plus this quarter, which is half. Half minus half, which is 0. We have equality here. Okay, so this one is telling us the limit of x sub n as n goes towards infinity, which equals alpha equals x sub 0, which equals half. Okay, now we are going to use the continue function. Now we are going to use f as a continue function. If a function is not continue, you cannot apply f on both sides. So we get here f, which means I'm going to apply f on both sides here. So we get a limit of f of x sub n as n goes towards infinity, which equals f of half. Okay, so it's very nice we get to this relationship. So we have determined the limit of f of x equals f of 1 over 2. Okay, we are simply going to apply the f on both sides here. So we get f of x sub n plus number 1 equals f of x sub n square plus quarter. So I'm going to use this definition that we have previously here. So by replacing x sub n with x, by replacing x with x sub n here, so thus I get f of x sub n. It's more simple, okay? By applying this recursion all the way down, because since we get this relationship f of x sub n plus number 1 equals f of x sub n, also is going to equal x sub n minus number 1, f of x sub n minus 2, and all the way down to the, when you get f of x sub 1 equals f of x sub 0, which equals f of half, okay? By applying this recursion all the way down, so we found a nice relationship between x sub n plus number 1 and x sub 0, which is half, okay? So which equals our limit here, okay? Half, which is constant. F is constant on this interval 0 and half, okay? Now let's get rid of this one and move on to the next step. So now we are going to define a new sequence on this interval. We will have x0 is strictly superior than half, okay? We have divided the interval into two parts, okay? So for this one, we are going to define a new sequence which is going to verify this condition. We have x0, x1 all the way down to the xn, which is x sub n plus number 1 square, which equals x sub n minus square, okay? So we have defined this one, this recursion, based on the condition that we have here, because we are going to show this sequence is decreasing sequence on this interval. So we have chosen this condition in order to have decreasing sequence, okay? So for this one, we are going to almost doing the same job that I have previously done, but this one is going to be a little different, as the function is going to change the behavior on the other side of the interval, okay? So we are going to prove x sub n is strictly superior than half also. We prove x sub n plus number 1 is strictly superior than half, okay? It's more simple. What's more simple here, we are going to take the difference, x sub n minus quarter. So we get x sub n minus quarter, strictly superior than half minus quarter is going to give us quarter, okay? So what to do now, I'm simply replacing this one with this one, okay? We're always using this one as a true assumption by using induction hypothesis here. So this one is going to be replaced with x sub n plus number 1 square, which is strictly superior than quarter. Let's take the square root on both sides. Thus, you get x sub n plus number 1 is strictly superior than half, which is true. We have proven this one, okay? If we are using this condition, which means you are going to prove this sequence un is a decreasing function. If you are using this inequality, un is strictly inferior than m, okay? Which means un will be increasing function, okay? So in our example, we are going to use this one, which is this one. Now we need to show this one is decreasing sequence, okay? X sub n plus number 1 minus x sub n. So x sub n plus number 1 is going to be replaced with square root of this one. Let's square that. So I get square root of x sub n minus square minus x sub n. So I'm going to rationalize this one by multiplying the same thing with a plus sign in numerator, x sub n minus square plus x sub n. All is divided by square root of x sub n minus square plus x sub n. Okay, is going to give us x sub n minus square after cancelling out the radical minus x sub n square divided by this thing which is positive. Okay, let's call it as capital A. This one, if I'm going to take minus sign out of these things, I get x sub n here square minus x sub n plus square all over capital A. Okay, so we get this one. Since with this we have a perfect square here which is positive, with this minus sign becomes negative. What does mean? Which means x sub n is decreasing. X sub n is convergent and is a convergent except n, which equals, as n goes towards infinity, which equals x sub 0, which equals alpha also. Okay, now we determine this alpha. We are simply going to replace this one with alpha square, applying the limit on both sides here. Limit of x sub n as n goes towards infinity, which equals the same thing, the limit of x sub n plus number 1 as n goes towards infinity, which equals alpha, which equals half, is continued function. So I'm going to apply f on both sides here. So get the limit of f of x sub n as n goes towards infinity, which equals f of half. Okay, by extraction out x sub n equals x sub n plus number 1 square plus 1 over 4. Let's apply f on both sides, since we have f is a continued function. So we get f of x sub n, which equals f of x sub n plus number 1 quaternary square plus quarter. By using this factor I have previously saw as an original setup, so replacing x with x sub n plus number 1, so we get f of x sub n plus number 1, so x sub n plus number 1, which equals f of x sub n, which equals f of x sub n minus 1, all the way down to the f of x sub 1, which equals f of x sub 0, which equals f, by applying the limit on both sides by using this fact, okay, which equals half. Okay, so without using this one, we don't know what's the limit of this one. By using these limits, we have determined this one. So since we get f of x sub n plus number 1 equals all the way down to this one, which means f is also constant for x sub 0 be strictly superior than half. In particular, f is a constant for x sub 0 on this interval 0 to plus infinity. Okay, by symmetry reason, this one is applied on all real numbers. Okay, so by the way, don't forget to hit the subscribe button and support our channel. Thank you for watching. We will see you next video. Bye.